Dear students, this is Dr. Srinivas, Master Academy of Mathematics. So I am just giving you the solutions of unit number 4 calculus part R18 R20 regulations JNTU Hyderabad Mathematics 1 paper. So once again you just look onto the unit number 4 calculus important questions, and for that I am going to give you its solutions. You just look onto once again the same solutions part, questions and along with solutions. So first one related to Rolle's mean value theorem. 4 bits are available here. These are the most important questions related to the final examinations. Second one, Cauchy mean value theorem. And third one, you are just expanding. It is totally no point is given, so indirectly you are using Maclaurin series. Fourth one, asking to evaluate the integral. Fifth one, you are calculating gamma of equal to root pi. Sixth one, you are proving one integral in terms of beta function. Seventh one, you are just calculating integral of sine power 7 theta. Eighth one, it's an integral in terms of beta function. Ninth one, you are calculating integrals using beta gamma function relation. 10th one, you are expanding tan inverse of x in the powers of x minus 1. So a point is given, you are indirectly using Taylor series. 11th, expand sine inverse of x, no point is there, Maclaurin's. 12th, expand e power sine inverse of x, no point is given, Maclaurin's. 13th, prove that a particular statement is given. 14th, a statement we need to prove it. 15th, prove that. So whenever a particular statement is given, in order to prove, maximum you are using Lagrange principle. 16th, you are finding the surface area. And 17th, finding the volume of the solid. 18th, you are proving one particular statement. 19th, integral value. And 28th, an integral value in terms of gamma function. These are the major important questions of unit number 4 calculus part. So for these questions I am going to give you its solutions also. Now look onto the solutions part here. The first one, you are verifying Rolle's mean value theorem for the given function. 4 bits are available. In that first bit, the interval is also given -1, 3. The first thing is Rolle's mean value theorem is going to have the interval, and we are identifying a and b values. Since it is a polynomial, always it is continuous in the closed interval. To verify the second property, you are just calculating the derivative, so it is differentiable in that open interval. And third property in Rolle's mean value theorem, f of a, that should be equal to f of b. So here f of a is 0 and f of b for the upper limit also it is equal to 0. So f of a equal to f of b. All the properties of Rolle's mean value theorem are satisfied. Then immediately you are calculating the c value belonging to the open interval. Condition is f dash of c equal to 0. So from that you are just calculating f dash of x at x equal to c, and finally you are getting only one value for c equal to 1. That one point definitely belonging to the open interval -1, 3. First bit over. Coming to the second bit in the Rolle's mean value theorem, function is given and you are just identifying the lower and upper limits. So anyhow it is a polynomial, it is continuous, and you are calculating the derivative. So since it is x into x plus 3 e power minus x by 2, you are using UV rule, and finally you are going to get one expression so that it is differentiable. And you are calculating f of a value, here it is 0 and f of b is also equal to 0. So that you are calculating f dash of c equal to 0. From that you are going to get c value. So here you are getting c value -2 and 3. For the given open interval, -2 is only the value belonging to the interval. So when 3 properties of Rolle's mean value theorem satisfied, automatically there exists at least one point c in the open interval. So third bit in the first problem, a function is given. Again it is verifying your just 3 properties. All the properties are satisfied. Then you are calculating f dash of c equal to 0 and finally c equal to 1, that belonging to the open interval. And then you are going to f of x equal to e power x into sin x. So from that the interval is given, and for that interval you are just verifying all the properties, and all the properties are satisfied, and immediately you are going to get the c value by using the condition f dash of c equal to 0, and finally you are going to get c value, that is 3 pi by 4, that belonging to the interval 0 comma pi. And the next problem, you are verifying Cauchy mean value theorem for the two functions f of x is root x and g of x is 1 by root x. If no interval is given, that means the standard interval is a comma b. If nothing is mentioned, a comma b is the standard interval only. So Cauchy mean value theorem, we have to use two properties. One is it is continuous because it is a polynomial, both the functions, and immediately you are calculating the derivatives of both the functions, and both are differentiable. So after getting that two properties, then immediately you are going to calculate the c value, which is nothing but f dash of c by g dash of c. The formula is f of b minus f of a divided by g of b minus g of a, and just you are substituting its values and making the simplification. You are getting the final answer is c equal to root ab, which is automatically belonging to the open interval. Third problem, expand logarithm of 1 plus e power x. So no point is given, you are using the Maclaurin series formula, and just you are calculating the right side values. Maximum of two values you need to calculate, and after getting that values, directly you are substituting in your Maclaurin's formula. So you are getting, this is the expansion. The next problem, you are evaluating the two integrals. So just whenever you are calculating the integral value of any particular integrand, you just identify the typical term which is available in the integral. For that typical term only, you start with a new variable, and just you find out the limits of new variable and substitute in the given integral. Automatically it is converting into gamma function, and finally you are getting the value. Similarly for the second problem also, the typical problem is e to the power of x cube is there. So start with x cube equal to t, and just you are finding the answer. Whenever you calculate the gamma function, if it is necessary, then only you can make the simplification. Otherwise you just leave the gamma value as it is. Nothing to worry, marks will be awarded. So we need to prove that gamma of equal to root pi, that can be calculated by using a relation beta function in terms of trigonometric. We simply call it as polar coordinates of beta function. From that you are substituting m equal to 1 by 2, n equal to 1 by 2, and just on substituting its value you will get an answer, and then you are using beta gamma function relation, and from that you are getting gamma of equal to root pi. The next you are proving the integral sin power m theta cos power n theta equal to that value. Again here you are using the polar coordinates of beta function, just you are identifying m and n, and from that you are substituting in the formula and just making the integration simplification. You will get your required answer. Seventh one, integral sin power 7 of theta. It is also by applying polar coordinates, identify m and n and substitute in the formula. You will get in terms of beta function. If it is necessary, you can convert into gamma, otherwise you leave as it is. So integral is there in terms of beta function. So just on making the simplification, and whatever may be the different term is there, you start with the t, and from that you are getting its values, and final simplification and making the integration, just you are getting in terms of beta function. Then you are evaluating that x cube into under root of 1 minus x, and these are the integrals. So just you are writing in terms of beta function, and here also. So finally you are getting, this is your final answer. Just you do the simplification, only the simplification is required. The next is like this. If it is necessary, then you make the simplification of beta. Otherwise, no need of making the simplification, you can leave as it is. Tan inverse of x, you are expanding in powers of x minus 1. So point is given, you are using Taylor series. So minimum you need to calculate two derivative values for the given function. Tan inverse, then directly that values are substituted. Here in powers of x minus 1 is given. So x minus something is there, that is nothing but your a point, and b always taken as x in Taylor series, and directly you can get your answer. Expand sin inverse of x, start with f of x equal to sin inverse of x, no point is there, Maclaurin series. You need to calculate 2 or 3 values of derivatives and directly substitute in the formula. E power sin inverse of x also same. Only the thing is you need to have the derivatives. Minimum you need to have it. Then directly you can substitute in the formula. And you need to prove this particular statement here. Whenever in order to prove that one in the mean value theorems, you are focusing on the central value. So here the middle term of the given statement, it is looking like sin inverse of x. So from that you are starting with almost you are getting the same. So after getting that middle term and Lagrange principle you need to apply, and after getting the c value make it as equation 1. Since c is belonging to a comma b, so from that c lies between a and b. Manaki left side equation of 1 is there, that you need to get from that. First you square it and minus multiplication, then 1 minus, then you take the square root and 1 divided by reciprocal. When you multiply with minus and taking the reciprocal, the sign changes, less than converts into greater than converts into less than. So by that you will get your final answer in terms of a and b. Then you focus on the given statement, sin inverse of b you need to keep in your middle term, where b stands for 3 by 5, and sin inverse of a is shifted to left and right side of that expression. So for which value of a you are going to get the common value in the given statement, that you look onto that, so that a equal to 1 by 2. From that you will get your required answer. 15th, same as it is, you are applying the Lagrange principle. After getting all the properties of Lagrange's principle, you are making it as equation number 1, and again applying the same procedure, c belonging to a comma b. From that you will get your required answer. Only the thing is you need to identify a and b values. So find the surface area of the given expression generated by one expression is given. Surface area along x-axis. So from that x-axis means y value is taken as 0. From that you are getting the x limits 0 to 3. And after getting that you need to calculate dy by dx from the given expression. So just for that dy by dx you are getting one value, and that value you are substituting in your surface area. The formula is 2 pi into integral over a to b y into under root of 1 plus dy by dx whole square dy, and that value you can substitute here, and directly root in order to cancel that one, whatever may be the dy by dx you are getting, that you need to write down in terms of factors. Then only on making the simplification you will get the answer. The factorization is important. Finally you are getting minus 3 pi. So you are getting the find volume of the solid enclosed by an expression is given, xy equal to 1 and x equal to 1 about x-axis. From that x-axis means you need to get the x limits. Then volume is nothing but pi integral a to b y square dx. That y square you are converting as per your given expression, and directly just making the simplification you will get the answer. 18th one, you are proving that modulus of cos b minus cos a less than or equal to modulus of b minus a. Such type of statements you can prove with the help of Lagrange's theorem only. First you verify all the properties that, and after getting the equation number 1, then just you are making your final answer From that, again you are selecting the point belonging to a comma b, and from that you are going to get your required answer. And then prove that tan x by x greater than x by sin x. Here two functions you need to take by applying the Lagrange principle. One function f of x equal to tan x, and another function is f of x equal to sin x. By taking f of x equal to tan x, you just calculate one expression, and finally you are going to get one equation. And similarly, and from that you are going to get the answer. And for second one, f of x equal to, you take sin x, and again on finding the simplification, you are going to get one more expression. And by taking the point belonging to that 0 comma x, so finally you are going to get that value. So by combining equations 1 and 2, you will get your required answer. So you need to prove that integral value. So very simple, just the given integral, you can just make the simplification, and you just identify the values, and making the simplification you will get your required answer. And 20 problem, and this 20 problem, it is somewhat typical. Only the thing is, in the left hand side integral, denominator a power x is there. We have a rule, e power log x can be taken as x. E power log x is always taken as x. In the same model, a power x, you can write it as e power log a power x. So by using that particular concept, you can find out your final answer. So this is about the complete problems regarding to unit number 4. It is calculus part. Just you prepare these different problems, you will get maximum score in the examination. So in the next video session, we will enter into unit number 5 assignment along with your solutions. All the best.